Welcome back. This is lesson 12.1/12.2 Statistical Questions and Data Collection Journal. I will be able to correctly identify a statistical question, and create my own. I will also be able to understand what data is, understand what data is being observed and how to accurately interpret the data. Okay, vocabulary for this lesson. You're also going to need the vocabulary page. Okay, vocabulary for this lesson. Data. Data is a collection of facts such as numbers, words, qualities, or observations. Statistics is the study of data. So it's using data to make predictions or decisions that are mathematically based on collected information. A statistical question is a question that can have multiple why did I have three there? Let's see. Multiple different possible answers, as well as I remember what it is. It's more than one, which is the same as saying multiple. So more than one possible answer, as well as more than one response. Answers must be different. Or the word I was looking for there was vary. Okay? Answers must vary. They can't all be the same answer. So if I ask, are you human? To every human, there's only going to be one possible answer to that. The answer is yes. If it varies, that means there can be different ones. So if I ask a bunch of people what their hair color is, everybody's going to have a different hair color. So I would get multiple different answers, right? As long as you get more than one possible answer, as well as more than one response. And the answers must vary, meaning they can be different. So vary, items can be different from one another. Okay, an attribute is the characteristic of an object or situation. Okay, quantitative data is data that can be measured or counted. Or counted with numbers. Qualitative data is data that describes something such as a characteristic, quality, or I don't remember what the third thing I was going to put there was. So these are non-numerical. So example, if something is good or bad, yes or no, colors, that kind of stuff that you can't measure. Okay? Or non-measurable. Okay, we have quite one more that we're going to do. Sample size. Sample size or observations is how many unique data entries are in your data set. Okay, it's the number of your sample size. I should say number of your sample size. Oh, no, I'm sorry. That is me making a mistake. The larger your sample size, so the more people you can interview, the more samples you can take, the more accurate your summaries will be. Sorry, the larger your sample size, the more accurate your summaries will be. If I only ask 2 people in the classroom what their favorite ice cream is, or if I ask the entire class what their favorite ice cream is, my data will be better for me to make judgments on because I will have more information. So the more information you get, the more accurate your summaries will be. Alright, that's all that we're going to put on there for now. So go back to the other page. Okay, we're going to decide if each of the following questions is considered a statistical question. If it is, underline the words that make it a statistical question. If not, state why it is not a statistical question underneath. So remember, a statistical question must have more than one answer and must be able to get more than one answer. So it says, Olivia asked her classmates, how many dogs do you have? Okay, classmates, she asked more than one person, so that meets that one. Can we have different numbers of dogs? Yeah, one person can have 0 dogs, another person can have 13 dogs. So these will be different, and she'll get more than one, so yes, this is a statistical question. Okay, Julian asked Jose, what is your favorite movie? So this is not a statistical question because he will only get one response. Okay, Mrs. Norris asked everyone in the class, who is the President of the United States? Okay, she asked everyone in the class, but at the time, how many different answers are there going to be for who the President of the United States is? There's only one President of the United States, so this would not be a statistical question. There is only one possible answer to this one. Felix asked everyone on the track team, what is your best time for the 100 meter? He asked everyone, so that means he's going to get more than one answer, and everybody is going to have a different time. So yes, this is a statistical question. So Grayson asked his friend, what time did you wake up this morning? He asked one person. Because he only asked one person, this would not be a statistical question. He will only get one answer. So, you have to have more than one possible answer, and you need to get more than one possible response. All right, let's talk about the different attributes we might measure. So here's the question. Miranda recorded the length of everyone's arm in her health class. What attribute was measured? This is the length of the arm. Possible units of measure. What could we possibly measure her arm in? Well, you have to determine, are we measuring it in millimeters, inches, feet, yards? So we could use centimeters, millimeters, meters even. We might also use inches or feet. Those are all possible units that we could use. Okay, what kind of tool would we use to measure that kind of stuff? Well, probably a ruler or yardstick. Meter stick if we're doing in metric. So is this a qualitative or a quantitative question? Okay, remember qualitative is a quality, quantitative is a number answer. So we would be getting numbers, so this would be considered a quantitative. Quantity. Okay, Xander recorded the color of his shirts people wore to school. So what are we measuring? We're measuring color. Possible units of measure. Not really measuring anything, so it would just be colors. Tool. This one's just going to be by observation. You can't really do anything other than watching it and seeing. Now this would be a qualitative because it is a quality that you're measuring, not something that we can do in numbers. So this would be qualitative. Okay, Alice recorded how long it took her dog to eat his food every night. So what are we measuring? Here we're measuring time. Possible units of measure depends on if it's a fast eater or a slow eater. It might be seconds. Could be minutes. And if it's a really slow eater, it might be hours. So what tool would you use to measure this? Probably a stopwatch or clock. Would this be qualitative or quantitative? Well, time is measured in numbers, so this would be considered a quantitative kind of data. Charles recorded how much his puppy weighed at each puppy weighed at the shelter. So this one would be measuring weight. That's the attribute we're measuring. What could we possibly measure it in? Well, if we want to do metric, we could measure them in grams or probably kilograms. If we're measuring it in the standard system, it might be ounces or pounds. So how would we measure ounces, pounds? Well, we would probably need a scale, weight scale. Would this be quantitative or qualitative? Once again, this would be measuring in numbers, so this would be a quantity, so this would be quantitative. All right, turn your page over. So, when collecting data, there are 3 key points to make it as accurate as possible. If possible, you want to record the data yourself. Why? If you just ask people what their heights are, they might lie to you. If you want to be accurate, you probably want to measure them yourself. Okay, it makes it so that all information, or it makes it so that you get it all firsthand and measure it in the same way. So example, you measure the height of everyone in class using the same ruler. You don't just ask people how tall they are. If you just ask how tall they are, some might lie to you, some might have no idea and just guess. But if you accurately measure, then you will know that everyone was measured against the same measurement. Okay, a second thing is to make sure that you get a large sample and don't just rely on volunteers. I didn't mean large there, sorry. You get a varied sample and don't just rely on volunteers. So example, if you're interested in recording data, for the whole class, for the whole school, collect data from every grade and not just the 6th grade. So if you were trying to gather information about favorite kinds of ice cream for the whole school, if you just ask 6th graders, you might get data that isn't as accurate for all the school. You might want to ask some kids from 1st grade, 2nd grade, 3rd grade, 4th grade, and 5th grade, also not just 6th graders. Okay, the other one is the larger your sample size. The larger the sample size, the more accurate your summaries will be, and predictions will be. For example, asking 5 people from the school, 50 people from the school will be more accurate than just asking 5. You want to also make sure that you mix that. You don't want to just pick 5 6th graders or 50 6th graders. You would want to maybe pick 5 from every grade. So when people are doing statistics, they like to have a mix of people. You might not want to just ask girls. You want to ask girls and boys. You might want to ask teachers and students. It depends on what you're gathering the data for. But do it yourself. Make sure it's mixed. And the bigger your sample size, the better your information will be. So based on that, select which of the following scenarios would give you the most accurate information. Then tell why you selected the option you did. So you want to compare how fast people can run in your school. So if we have 30 volunteers run around the track and tell us their times, we could also select 30 random students and you record their times. Have 7 track team members run around the track and record their times. Select 30 random 5th graders and have them state their times. Or select 7 random students and record their times. Which one is going to help us get more accurate information? Well, the first one is, if they're telling you their times, that's not going to be very accurate. They want to seem as fast as possible. Some might not tell you the truth. However, having more is better than having less. So having 30 would be better than having just 7. Now, if you pick 7 from the track team, then if they're on the track team, they're probably pretty good already. So if you're trying to compare for the entire school, would pulling them from the track team help you be as accurate about the rest of the school population? No, you're going to have your fastest people that want to run and practice every day. And if you record their times, that's okay, but by picking from the track team, that doesn't accurately reflect all of your school. If you only pick 5th graders, then that also only that would only be accurate for 5th grade, not for the entire school. If you have volunteers, you might only have the ones that want to run. So if you want the best information based on how the whole school is doing, you would want to select 30 random students. So you want to get a random sample, meaning a mix of everybody. We also want as many as possible, so 30 is better than 7. And if you record their times, it's going to be more accurate than them telling you. So we are going to select B because the sample would be random. So the sample is large, random from the whole school. And you record their times. Okay, number 2. You want to compare summer average high temperatures around Utah in 2020. So what would you do? Research and record 30 random temperatures from Kanab from 2020. Ask your friend to look up 20 different temperatures from Utah during 2020. Research the average high temperature for 40 random places in Utah during July and August of 2020. Record the highest temperatures of each day for towns in King County for June 2020. Or research the highest temperatures each day for Salt Lake City and Kanab for 60 random days during 2020. Okay, right here you want to compare summer average high temperatures from around Utah. So if you stick to just Kanab, is that going to be an accurate depiction of the entire state? No. Also, we didn't say when. Random is good, but since we want summer average, if you're finding a high temperature from January 21st, it's not going to help you for summer average temperature. If you ask your friend to do it, they might just make up a bunch of stuff just to give it to you because they don't want to do it. You should probably get the information yourself. Research the average high temperature for 40 random places in Utah during July and August. Okay, right there. That's giving us summer months, which is what we want. Random, all over the state of Utah. And 40, that's a fairly high amount. So far, that one's sounding best. Record the highest temperatures for each day for towns in King County in June. June is in the summer. However, just King County doesn't accurately reflect Utah. So if you're trying to do from around Utah, King County doesn't cover all of Utah. Research the highest temperatures for Salt Lake City and Kanab for 60 random days. Well, random days, once again, could be February, which is not summer. So we're going to select C. Why? Because it would be the summer months. And it's information from all around the state. And 40 random places, it's not just 2 different places. And it has a large sample size. Alright, hopefully that makes sense about how to collect data, how to make it accurate, and also what a statistical question is. Rate yourself on this concept, 0, 1, 2, 3, or 4. Take pictures and turn it in on Google Classroom.